Good afternoon. It is a pleasure to be at ICL 2021. I am here to introduce the Floating Trash Collector, an EPS at ISEP project. EPS stands for European Project Semester, and ISEP is the School of Engineering of the Polytechnic of Porto. EPS is a project-based learning framework where teamwork, sustainability and ethics are the main pillars of project development. In the spring of 2020, these 5 students from different study fields and nationalities joined efforts to tackle the problem of garbage floating on the water. I will leave you now with the students' presentation.
So the problem we want to help tackle in this project is the trash in natural waters. Every year, 8 million tons of plastic ends up in the ocean. And what's making it an even bigger problem is that this problem is not feasible for people. So that's why our goals for the project are first to raise awareness for this problem, so the trash in natural waters. And secondly, we would like to build a product that contributes to collecting floating trash in natural waters, and that does that continuously and automatically. Also, we want our product to be sustainable, so made of sustainable material and using renewable energy if possible. And we have to use open source technologies for building this product. Then how did we manage our project? We managed our project with the Scrum method, but we applied it differently in reality than we initially planned. We thought we would have our sprints from Monday until Friday, but in reality we had our sprints from Monday until Monday. So we had our sprint planning, the review, the retrospective all Monday, so we could directly start with a new sprint and correct our mistakes and start with the new tasks. We didn't have the daily stand-ups we thought we would have, but we had meetings when necessary. So when a team member wanted to meet, we had a meeting. And we didn't have the visual sprint planning in the classroom because of the crisis with the corona. But we had it online on the Microsoft Planner.
In order to develop this project, we first analyzed what's already on the market, and we came up with 3 categories represented by the Sieving project, the waste shark, and the ocean cleanup. We analyzed these categories by different criteria such as autonomy, efficiency, and so on. And in the end, we decided to go with a solution that is very similar to the Sieving project. When we developed the 3D model, we had in our mind that the product is going to be in a lake and it is going to have a submersible pump. Then we started to create it to make it float. For example, in the photo that you can see in the top right corner, you can see that it has a black ring. Well, that ring would help it float, but it would prevent the trash from going in. We gave up on that solution and we went with some tree petals made out of cork. The problem was that, okay, cork is a product of Portugal, and that's good, but cork cannot be easily merged with other materials, just plastic, without it having holes in it, and because of that, it would cause it to break. And in the final picture, you can see a solution that is very close to our final solution. This is the final solution that we have, and in the picture you can see the product working on a lake, and you can see the level of the lake rising to the top margin of the inner bin. I'm saying the inner bin because the product has 2 parts. The part that is going to stay in the lake when the inner bin is taken out, so we can empty the bin. The materials that we used are mostly plastic, different kinds of plastic, and stainless steel because of the environment that we work with. So we have different kinds of plastic. For example, we have PET for the main body, the transparent that you can see. But for example, for the blue parts and the yellow parts, we have acrylic, because that is UV resistant and those parts are exposed to the sun.
All right, now going to the electrical development of our product, I'm going to talk to you about a little bit of the black box diagram that I presented here. As the floating trash and water fall into the collector basket, we have some sensors in it to make some measurements. So we have the ultrasonic sensor to determine the level of the trash inside the bin, the water level sensor to determine the water level inside the bin again, and the temperature sensor to determine the temperature of the water again inside the bin. All this data from the sensors will be sent to the microcontroller. That is the brain of all the system. There, the microcontroller will process the information that comes from the sensors and will either control the motor of the water pump by turning on or off depending on the conditions of the sensors. But it will also, most important, send the information to a web page via a Wi-Fi interface. There, the user can see when to intervene in the system and the problems that the system might have in this instance. Another important feature to note is that our product can be powered by two ways. One via a more traditional way, the power grid, and another one that's using renewable energy, more specifically a photovoltaic panel.
To regulate the buoyancy and to make sure that the level of the lake reaches the top margin of the body, we needed to make sure that we add a 26 kilograms weight, which was made of stainless steel. But we need to make sure that the body resists such a weight, and we consider the worst case scenario, and that is, for example, when the user holds the body by only one of the parts. This is not likely to happen in real life, but if this situation works, it means that the body is all right and works in every situation. So we considered two scenarios. The first one, when the body is outside the lake, and the other one on the bottom, when the body is inside the lake. The difference between these two scenarios is that in the first case, we have the gravity force and the load from the weight. And in the second scenario, the hydrostatic pressure is added. We can see that in both cases, everything is all right, both the safety factor and the stress levels, and the body has no potential to break.
Now, moving forward into the simulations, I would like you to present our circuit that we use to simulate. We use the Thinkercad platform because it's open source, it's free to use, and it's very easy to interface, although there's some limitations in the components. Most particularly in our project, we had the limitation of microcontroller. Instead of our plan to use one microcontroller with Wi-Fi capabilities, here in the simulation, we're using one microcontroller specifically to process the information that comes from sensors and control the motor, and another one, another microcontroller that allows the communication with the web page. Another important component to point out is that there was no component of water level sensor. So we substitute it by what's called a potentiometer. Although this is a good solution because both of them are very simple components that use a change in resistance to show the changes, the physical changes. And now moving forward, I would like to present with the IoT platform, and which chose to use the ThinkSpeak. We chose this platform because it's once again it's free to use, but also it's very easy to interface with Thinkercad. Sorry, because we can use this to interface what's called an API key. Okay, now I'm going to go into a little bit more detail about the dashboard that you can see here. Okay, in the top left, we have what's called the bin capacity. This is a gauge meter that displays the current capacity in a percentage. Not only it displays, well, the capacity, but also gives alerts to the user. As you can see here right now, it says capacity in the middle, but when it reaches this red zone, you can see here on the right, it will turn to full. When there's some reading that it goes out of the normal range operation, it appears as an inconclusive reading. Again, when the sensor is completely lost, it displays 0, it will here display the text sensor lost. And another very specific situation is that when there's no data to be displayed. That usually happens when we are first configuring. And now I will like to talk to you about some future developments. Of course, we develop a prototype here. But the final product will need, of course, to scale up the components, but most important is the water pump and the physical materials that there need support. And also, I might add that changing the water pump will also, of course, change the powering circuit. Although there's another feature that I would like to implement in the future development, that is to measure the actual quality of the water. For this, we will need at least these 4 sensors. So we have the dissolved oxygen sensor that allows us to measure the oxygen level in the water. It's very important for life in the water. The salinity sensors allow us to measure the concentrations of dissolved salts inside water. What's called the oxidation reduction potential sensor, OPR for short, that allows us to measure the bacterial concentration inside water, and the turbidity sensor that allows us to actually measure the cleanness and transparency of the water.
Now we have the video.